Hello, Cappuccino. I am going to be doing problem number 15 from page 200, and it's about composite functions. So first I want to point out that they didn't draw the little circle, the little composite circle in the textbook. I don't know why. I have never seen it written the way they had it in this problem in the textbook before. But when they wrote this, g f of x, they mean g of f of x, okay? So on question 15C, they wrote f g f of x. They mean f of g of f of x. So weird notation, okay? I know, very strange. In order to solve question D, we're going to have to do a little investigation. So I'll get back to that, but I'll go ahead and start out with problem C. So we know that g of f of x is this guy right here. So we are going to put that into f of x. Here's f of x. So we're going to take all of this and we're going to slide it in right here. So f of g of f of x is the same as this guy, but with this in parentheses. So my x is going to be 2x squared plus 18, and then my minus 24. So if I simplify that, I get 2x squared minus 6 is equal to all this, but in the problem, it says I want to set it equal to 0. So f of g of f of x is going to be 0. So I'm going to substitute in my 0. Now I just need to solve for x. So I'm going to move my 6 to the other side, add 6 to both sides. 6 equals 2x squared. I'm trying to get x by itself. So to get rid of the 2, I need to divide by 2. So 3 is equal to x squared. And now to get rid of the exponent, I need to take the square root. So I'm going to square root both sides. And since it's a quadratic, there's two answers. X is equal to plus or minus the square root of 3. Okay, so that is question C. Question D asks, what is g of x? What is g of x? Well, we know that g of f of x is equal to 2x squared plus 18. And we know that f of x is equal to x minus 24. So what can I do with these to separate out the g from the f of x? Well, I was really stumped. I didn't know what to do. So I did a little bit of research, and it turns out what we're going to have to do is we're going to have to use the inverse function. So this is where I want to take a little break. I'm going to do just a little experiment here. So if I have f of x and I have g of x, and I want to find g of f of x, okay, so I'm doing it with two functions that are unrelated to the problem. I'm just going to do a little messing around. If I put my f of x in here into my g of x, I'm going to get x plus 2 squared minus 3, okay? So, and then I could simplify that out. I can multiply out x plus 2 times x plus 2, and I end up with x squared plus 4x plus 4, if I multiply that out, minus 3, which is equal to x squared plus 4x plus 1. So g of f of x is equal to this. So if I was told, okay, this is f of g of x and this is f of x, I am not going to see it in here at all. I'm going to be like, what are you talking about? It would be easy to figure out what it was if I had left it in this form, right? I'm going to go, oh, if I didn't know what f of x was, but I knew g of x was x squared minus 3. Oh, well, it's right there. Okay, but the problem is that after we've simplified it, I no longer can see that f of x. It's kind of hidden in all the manipulations we have done. So I can't just solve this by inspection. If I had left it like this, and I knew this was g of x, and I knew this was g of f of x, then I would see it right here. And I go, oh, that must be f of x, because the only difference between that and that is right here. But once I've simplified it, oh, forget about it. Where's the x plus 2 in here? Where is it? It's disappeared, okay? It's a minefield. So what I want to think about is how can I undo the putting in of f of x? How can I undo the f of x part? So I want to think about what's the opposite of f of x. Because when you think about like solving an equation, so say I had 2x is equal to 10, how can I undo the times by 2? I undo it by doing the inverse operation, which is divide by 2. So if I have something's being times by 2, I do the inverse operation to make it go away, and I'm left with what x is equal to. So my operation here is this f of x. I have this f of x, and I want to do the inverse of it. I want to do the inverse of the f of x to get rid of the f of x. Okay, so multiplying by 2, the inverse was dividing by 2. F of x is what happened to this. We put an f of x in here. What's the inverse of f of x? Okay, to undo it, we're going to do the inverse. So let's give it a try. The inverse function, how do I get inverse of f of x? So f of x was x plus 2. So to get the inverse, we're going to change this to y equals, and then we're going to swap the x and the y. So the inverse, I'll put it over here, is going to be x equals y plus 2. I'm swapping the x and the y. Then I got to solve it for y again. So I'm going to minus 2, and I get x minus 2 is equal to y. So the inverse of f of x, is equal to x minus 2. So now if I take my g of f of x, and I combine it with the inverse, these should cancel each other. These should cancel each other out. F of x composited with its inverse, they just cancel each other out. Just like 2 divided by 2 cancels each other out and you get 1. F of x composited with its inverse, they cancel each other out and you're left with 1. So let's see if that's going to work. So I'm going to take my g of f of x, which is right here. I'm going to take that, and I'm going to substitute in my inverse function. I'm going to substitute in my x minus 2. So right here and right here, I'm going to substitute in my x minus 2. My goal is that this will get rid of the f of x, and I'll just be left with g of x. So let's see what happens. Okay, so I'm going to take my x minus 2. I'm going to put it in x minus 2 squared plus 4 times my x gets replaced with x minus 2, and then plus 1. Okay, I'm crossing my fingers now. I hope this works. This was new for me also. All right, so let's see what happens. X minus 2 squared, I got to multiply it out, plus, let's distribute that, 4x minus 8, still have my plus 1. Okay, let's multiply this out. X squared minus 2x is minus 4x. Negative times the negative is plus 4. Let's keep going. Okay, this is my only x squared. Negative 4x plus 4x. Oh, those cancel out. 4 minus 8 is negative 4. Negative 4 plus 1 is negative 3. So the f of x canceled out the inverse. It cancels with its inverse, and we're left with g of x is equal to x squared minus 3. Is that what we started with? Holding my breath. Yes, ding, 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 ding. There it is. That was my original g of x function. Okay, so if you are given composite function, so like we had g of f of x, you're given the composite function, whatever it is. If you want to get back to just the g of x, you can get the inverse function composite with the inverse function of x, of f of x, and that will leave you with just g of x. Bam. Who knew? Craziness, okay? Because the function, when you composite it with its inverse, those end up canceling out, okay? When you composite a function with its inverse, that just equals 1. and you're just left with your g of x. Okay, so back to the problem that we need to solve. We were given g of f of x is 2x squared plus 18. F of x is x minus 24. I do not see an x minus 24 just sitting in there. I can't just like solve this by inspection. So instead, what we're going to have to do is we're going to have to find the inverse, because if I can do g of f of x of the inverse, that will leave me with g of x. These will cancel out. All right, so first thing, I need to find the inverse of f of x. Okay, so the inverse of f of x, I'm going to change my f of x. I'm going to change it to y equals. And then I'm going to switch the x and the y. Solve it for y, so add 24. So my inverse, -1 of x is equal to x plus 24. Now I can take this and I can put it in to this function right here, my g of f of x. I'm going to put in my inverse function, and when I simplify it, I will be left with g of x. Okay, so g of f -1 of x, that's another way of writing it. Okay, that's going to be equal to 2 parentheses x plus 24 squared plus 18. And I'll let you take it from there. Okay, hope that helped a little bit. That was a really tricky one.